In this video, we're going to derive the law of cosines. So the law of cosines. Now, what is the law of cosines? Now, the law of cosines works quite similarly to the law of sines, except in this case it's cosines. It's actually a little bit more interesting. And pretty much the idea of the law of cosines, again, we're going to draw a triangle just like we did for the law of sines. So actually, I'm going to draw it like this. I'm just going to do a little something like this. So this right here is pretty much a triangle. And what I'm going to do is I'm going to label this right here point C. I'll label this point A, point B. I'll call this pretty much opposite of point A, side A, opposite of point B, side B, opposite of point C, side length C. Now, for the law of cosines, actually, it turns out we won't actually need point B or point A, because I just don't want to confuse people by what I'm doing. Now, the idea of the law of cosines is it pretty much relates side A, side B, side C, and angle C. And so the idea of the law of cosines is that some people like to refer to it as the Pythagorean theorem, except it works for any triangle. And that's what's really cool about it, and what makes it, in my opinion, more interesting than the law of sines. So, how can we relate these three sides and this angle with each other? Now, it turns out we're going to have to use trigonometry because it's cosine, right? And in order to do trigonometry, we need right triangles. So the easiest way to make a right triangle is to do this, where we construct an altitude of the triangle. And I'll call this the height of the triangle. I'll call it lowercase h. So we'll call this the height of the triangle. And it turns out we're actually going to need to know this side and this side for the triangle in order to relate these four things together. So I'm actually going to call this length L. And so if this is length L, then this length right here has to be A minus L, right? It's pretty much a geometry thing. So A minus L. And so yeah, we have these three things. Now that we have that, how do we actually figure out the relationship between these four sides? We're going to use trigonometry, right? So it turns out that when we're using trigonometry, really much what we're doing is we know A, B, and angle C solve for side length lowercase c. Well, what is side length C? What is this? Side C, we could represent it using the Pythagorean theorem. C squared equals L squared plus H squared. So C squared equals L squared plus H squared, right? Just the Pythagorean theorem. But now what we have to do is we have to find what L is in terms of A, B, and angle C. And we have to find what H is in terms of A, B, and angle C. That's all we have to do, and we will have the law of cosines. We'll solve for C. So, what we're going to do in order to do that is we're going to have to find H first. So to find H, I'd say the easiest way to find H is we could say the sine of angle C is equal to H over B. So yeah, let me just do this. The sine of C is equal to H over B. We know that. We could then solve for H because that's what we have to solve for. H is equal to B sine of C. And that works really well because it's in terms of B and angle C, which is what we need in order to find C. So yeah, this is pretty much all we have to do for H. So now that we have H, we got to deal with L now. So for L, you might be thinking, well, L is right here. Let's just use this triangle. But what's the problem with that? The problem is we'd have to use one of the angles in this triangle. We have to use this one or this one, but we won't be including angle C. So using this triangle isn't really that good of an idea. So instead of using this triangle, why don't we just use the other triangle? It also contains L, doesn't it? It contains it right here. So we could actually use this sine length. We could say that the cosine of C is equal to A minus L over B. So let's just do that. So pretty much the idea is that the cosine of C is equal to A minus L over B, right? A minus L over B. And after that, we have to solve for L. So in this case, A minus L is equal to B cosine of C. And solving for L, right, add L, subtract that, we get A minus B cosine of angle C. So we have figured out what H is and we have figured out what L is in terms of A, B, and angle C. As you can see, it contains B and angle C, contains A, B, and angle C. So this is going to work out really nicely for us. So knowing all this stuff, going back to our original C squared equals L squared plus L squared, or L squared plus H squared, we could say that C squared is equal to L squared. So we're going to take this thing right here and square it. So we have A squared, or not, that's not what I'm doing. That's not what I'm doing, right? I'm just getting ahead of myself. We're taking this entire expression right here, A minus B cosine of C, and we're squaring that because that would be L squared. And then we're adding H squared to that. So we're adding this term squared. So B sine of C squared. So all we have to do now is simplify this. And that's it. That would be the law of cosine. So let's just simplify this. And when we're simplifying this, notice how we're pretty much going to say A squared. So how do we expand something like this? This is similar to the idea of A minus B squared. So if you were to expand this out, you should pretty much just have to know that it goes A squared minus 2AB plus B squared. I'm assuming you guys already know that, right? Pretty simple. I mean, you guys could figure that out for yourselves. And we're going to apply this idea to this. Otherwise, you could just FOIL, do A minus B times A minus B, basically. So pretty much what you're going to get from expanding this out is A squared minus, all right, it's going to go 2AB cosine C, right, just expanding it out like we normally would, plus this term squared. And when you square this, you get B squared cosine squared C, right? So this term right here is what we had right here. So we're just going to add this. When we add that, it's B squared sine squared of C. So B squared sine squared of C. So this is what we have. And now notice something really cool, right? Turns out, look right here, with these two terms, we could factor out B squared and say that this is the same thing as just cosine squared plus sine squared, okay, obviously cosine squared of C plus sine squared of C in the parentheses, right? So that would be that. And when we do that, all right, I think we're going to have enough room, right? We will. All right, I'm just going to rewrite everything we had above this. When we have this, right, this is what we have now because we factored out B squared. Cosine squared plus sine squared of a specific type of angle, right? We know that's just equal to 1. So it's just going to be B squared. That's all we have. And so we now have A squared plus B squared minus 2AB cosine of angle C. This right here is the law of cosines. That's pretty much how it works. And yes, it will work for an obtuse triangle as well. You could show that it would work for an obtuse triangle as well. And so this is the whole idea of the law of cosines. And unlike for the law of sines, if you know the cosine of an angle, you can always find the angle because the cosine of any angle from 0 to 180 degrees always has a different cosine value. So you can, if you know the cosine of an angle, you can always find that angle in the triangle. So there's nothing really too difficult about that in the law of cosines, right? Now, it's interesting because notice how C squared equals A squared plus B squared, that looks really similar to the Pythagorean theorem, except it has one addition to it, right? It has the part where the angle is accounted for because it's not a right triangle. So it turns out this right here would be like the Pythagorean theorem for any triangle. And that's pretty much it.